Astronomers found objects in space that absorb almost all light. They are darker than charcoal, darker than any paint on Earth. In plain terms, darkness means extremely low reflectivity. A single black hole can swallow light, leaving a dark silhouette. A black hole is a region where gravity traps light forever. We care because they redefine what dark can physically mean. Light falls inward, photons orbit, then cross the horizon. The event horizon marks the boundary where escape becomes impossible. The black hole's shadow is visible against glowing gas nearby. The Event Horizon Telescope captured such a shadow in 2019. That image shows a bright ring surrounding a dark center. The dark center is where photons vanish due to gravity. So black holes are literally the darkest objects by definition. Bottom line, their darkness comes from trapped light, not shade. Some galaxies are so faint, they almost disappear into darkness. Ultra-diffuse galaxies spread stars thinly across huge spaces. They matter because they test our ideas about galaxy formation. Low stellar density means little light, but gravity still acts. Astronomers measure rotation, then infer mass that stars don't explain. Dragonfly 44 appeared almost invisible in deep images. Initial studies suggested a huge mass and little starlight. Later work revised numbers, but the galaxy remained very faint. So these galaxies show darkness can be structural, not absolute. Deep nebulae hide inside dark, cold clouds of dust and gas. A Bok globule is a compact cloud that blocks starlight. They matter because they are stellar nurseries and obscurers. Dense dust grains absorb visible light and scatter infrared. That process makes the cloud look jet black against stars. Telescopes using radio waves pierce these clouds and reveal cores. For example, the Horsehead Nebula shows a striking dark silhouette. Inside those silhouettes, new stars quietly begin gathering mass. Net result, darkness signals places where light cannot escape. Some asteroids and comets are surprisingly black on their surfaces. This darkness describes a low albedo, meaning weak reflected light. We care because surface composition reveals history and resources. Spacecraft measure sunlight reflection across colors to estimate albedo. NASA's OSIRIS-REx measured Bennu's surface as about 4% bright. JXA's Hayabusa 2 found Ryugu similarly dark, near 5%. Organic molecules and tiny porous grains trap light, reducing reflectance. Comet 67P has surface reflectivity under 6%. These dark rocks absorb heat differently, affecting their trajectories. Quick mental image, a charcoal pebble in sunlight in space. So asteroids and comets can rank among the darkest objects. Data from probes gives precise numbers and lasting surprises. Most of the universe's mass hides in invisible halos around galaxies. Dark matter is unseen, inferred from gravitational effects on visible matter. This matters because it dominates how galaxies assemble and move. Stars orbit faster than expected, signaling extra unseen mass. Simulations show halos shaping filamentary cosmic structures across millions of light years. We cannot see dark matter directly, but its gravity is measurable. For example, galaxy rotation curves reveal flat speeds at large radii. That observation implies mass extends beyond luminous stars and gas. Bottom line, darkness here means invisible mass shaping cosmic structure. The Milky Way wears dark lanes that cut across its glowing disk. Dust grains collect along spiral arms, blocking and reddening starlight. This matters because dust hides regions rich in star formation. Absorption removes blue light more efficiently, making objects appear redder. Maps of dust extinction show dramatic dark silhouettes across the sky. Infrared telescopes penetrate these lanes, revealing hidden stellar nurseries. The galactic center looks obscured in visible light and glowing in infrared. So dust is another form of darkness, shaped by environment. Net result, our view of the galaxy depends on dust's presence. Modern telescopes measure darkness using light curves and spectroscopy. This matters because precise measurements reveal composition and structure. Photometry tracks reflectance across wavelengths to derive albedo. Radio and infrared penetrate dust, exposing hidden cores and stars. Gravitational measurements infer dark mass where light is absent. Recently, new surveys found more ultra-faint galaxies in dark clouds. Simultaneous datasets let astronomers map darkness across multiple scales. Quick test: compare visible maps with infrared maps to spot hidden regions. So better instruments turn invisible darkness into measurable information. We met objects that absorb nearly all light in different ways. If you liked this journey, consider subscribing for more space stories.